Steve's Physics Videos. I'm Steve, and in this video we're going to be solving a problem where a 14 kilogram box is suspended by two wires, and it's shown in the picture above me. We want to find what is the tension in wire 2, the one on the right hand side. So go ahead, pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Let me show you how I solved it. So the first thing I did was I listed all of the known variables from the problem. So in this case, we know the mass of the block, and we know the tension in wire 1, and we know the acceleration due to gravity, and we know the angle of both of the wires coming into it. Next, I drew a force diagram for the box that's hanging there. For this box, you know there's going to be three forces acting on it. There's going to be the two tensions going off at an angle, of which you know the force of one of them, and you know the angle of both, as well as you know that there's going to be gravity going down, and we can figure that out. Also, another key piece of information here is that in the question it says that the block is hanging motionlessly, which means that it must have no acceleration. And if it has no acceleration, that means that the net force acting on it is equal to 0, which is a very important piece of information to note, because all of the forces in the x and y, x direction, and this is really important to note because all of the forces in the x direction must then add to equal 0, and all of the forces in the y direction must also add to equal 0. To begin solving this, I'm going to only look in the x direction because I think that will lead me to my answer. And I'm going to find the x component of the tension in the wire that I do know. I'm going to use the equation force in the x direction is equal to total force times the cosine of the angle. And when we plug in what we know, we find that the x component of the force in string 1 is equal to negative 52.99 newtons. Now, because we know that the total force in the x direction must equal 0, that means that the other force in the x direction from the other wire must equal positive 52.99 newtons. Now when I use that same equation again, but now with the other angle, I plug that in and I find that the overall tension in the other string is 68.19 newtons, which is the force of the tension that we were looking for. Hopefully that wasn't too bad for you. If you do have questions, please leave them down in the comments below, and I'll do my best to answer them. If you found this video helpful, please leave a thumbs up and subscribe to my channel for more content just like it. And until next time, have a great day.